This video is going to cover more factoring techniques. So our steps for factoring don't change. First thing we need to do is we need to pull out the GCF, the greatest common factor. Then we need to determine the number of terms and choose the appropriate method. So in this example, we want to factor 4x squared minus 36. So first step, always make sure you pull out the greatest common factor. So just to kind of review again, greatest common factor you can just look at, or you can write prime factorization. I'm just going to write prime factorization here so that way we make sure we get the greatest common factor and not just a common factor. So 4x squared is 1 times 4 times x times x. But 4 is not prime. 4 breaks into 2 and 2, which are both prime. Then we have negative 36, which is negative 1 times 36. 36 is not prime. 36 breaks into 2 and 18. 2 is prime. 18 is not. 18 breaks into 2 and 9. Again, 2 is prime. 9 is not. 9 breaks into 3 and 3. And then we look to see what each of these have in common. Hopefully you realize there are 2 pairs of 2's. So 2 times 2 is 4. So my greatest common factor for this is going to be 4. And then the stuff that's left over, 1 times x, which is x squared. And then negative 1 times 3, which is negative 9. So I've factored my polynomial. But again, always make sure you factor it completely. So yes, you did pull out the GCF, but always try to factor what's left over. So I want to try to factor the x squared minus 9. All right, so first thing we need to do, we know there's no GCF as we already had pulled it out. So next thing we need to look at is how many terms are there. There are 2 terms. So we're not dealing with 3 terms, we're not dealing with 4 terms, we're dealing with 2 terms. So we have 2 different methods here that we can approach. We have the difference of squares, and then the difference, and that should say of, sum, or difference or sum of cubes, oh my god. All right, difference or sum of cubes. So when we look at this polynomial, I see it as a square term. So I'm going to use the difference of squares method because it's a squared term. If there were an x cubed, that's probably when I would use the cubed scenario. But since it's only x squared, I'm going to use the squares scenario. So the steps for difference of squares is make it into 3 terms and then follow the AC grouping method. Again, if you've learned another method besides AC grouping, feel free to use that. But you want to make it into 3 terms in essence. So how can I make x squared minus 9 into 3 terms without really changing the problem? So hopefully when you look at this, you see that there's no x value in that. So what I'm going to do is I'm going to put that in, that there's no x value. So if I'm going to put in no x value, I'm going to put plus 0x. And then I have my minus 9. Now I have 3 terms. This has not changed the problem at all. There's no x's in the original one. I just put in that there's 0 x's. So this really hasn't changed the problem. It's just changed it from 2 terms to 3 terms now. And we know how to factor a trinomial. That's what we've been doing all in the last section, and it's what we did in the last example to start off with this section. So I'm factoring this now using any method that you know of how to factor a trinomial, 3 terms. Again, I'm comfortable with AC grouping, so I'm going to follow those steps. So I need to identify the A, the B, and the C. The A in this case is 1, the B in this case is 0, and the C in this case, negative 9. So I've identified my A, B, and C. Next thing I need to do is I need to multiply A and C. which is 1 times negative 9, which gives me negative 9. And then from there, I need to list every set of two numbers that multiply to negative 9. We're multiplying to negative 9. Pay close attention to that. So if I have 1, I have to multiply it by negative 9 to get to negative 9. But don't forget I also have negative 1 times 9, which is negative 9. Hopefully you realize 9 is not even, so none of the even numbers will go into it. So 3 goes into it, and a negative 3, which means I also have negative 3 and 3, which again, in essence, 3, negative 3, negative 3, 3, those are exactly the same. They're just, I flipped the position. So I'm not going to write that second one again. If you want to, it's fine. It's not going to hurt you, but you don't really need it there. And then 4 obviously won't go into it. 5 does not go into it. 6 won't because it's even. 7 does not divide into 9. 8 is even, and then 9 is already written. Or you could have kind of looked at it as you cycled up to the other side with a 3. So these are my only pairs of factors. So next thing I want to do is I want to determine which of these add to my b. My b in this case is 0. So which of these add to 0? Hopefully you see here 3 and negative 3 add to 0, which means I rewrite my middle term as 3x and negative 3x. So the x squared of the first term will never change, and neither will the last term of negative 9. But I will have my middle term changing to plus 3x and minus 3x. 4 terms now, so factor by grouping. Group the first two, group the last two. Greatest common factor of the first two will be x. Stuff that's left over is x plus 3. My second two terms, greatest common factor, negative 3. Stuff that's left over is x plus 3. Again, make sure you realize you're dividing negative 9 by negative 3. Negative divided by negative is a positive. And then hopefully you see there's an x plus 3 that they have in common, so I'm able to factor out that x plus 3. The stuff that's left over in the first part is an x. Stuff that's left over in the second part, negative 3. Please realize, yes, this is part of our answer, but it's not our complete answer because we originally factored out a greatest common factor. So I have to account for that. So my factored form of the polynomial 4x squared minus 36 is 4 times the quantity x plus 3 times the quantity x minus 3.